Hello guys, this is Rage Game Dev and welcome to the first episode in this tutorial series on how to create an entity component system in Lua used for Love2D or even Corona SDK, or hell, you could even take what you learned here and use it for any framework, that you'd like. So getting started today, I'm going to be talking about what an actual entity component system is. So let's start by talking about the traditional routes that people take when creating entities and stuff like that. So the traditional route is to have a base entity, right? And then you have, in the entity, you'll have common properties that you'll share between all of them. For instance, most entities need an X and a Y position, a width and a height for like checking if there's intersections or something, a velocity, health, damage, things like that. And then each entity will derive from it or extend from the base entity class. So you can see this pirate, extends it and then adds its own content that makes that pirate unique. So like, for instance, AI pathfinding, it has a weapon, like a hook or a cutlass, and then it has armor or whatever. That's code that's specific to the pirate. But not necessarily, because if you look over here on the ninja, this, by the way, just imagine this says, like, I don't know, katana. I forgot to change that. But you'll see that they use the same AI, they have the same cloth, or like they have an armor, variable and stuff like that. And there's a lot of code rewrite when you work in the system. And the solution to this is you make another base class that derives from entity that pirate and ninja can derive from. But doing that can be really messy, and you have to usually rewrite a lot of code to actually get that to work well. And it's not very modular, because let's say, let me go to my next slide. Let's say, for modding capabilities, let's say you want your modding community to be able to make new entities. Well, with that structured system, you have to have the source code, you have to be able to compile it, you have to understand it very, very well, and you can't really create your own unique entities like that. Dynamic creation, let's say you want to create an entity just off a string or a file, data that you have in a file, or maybe a Lua table or something like that. And then, yeah, modularity, it's very monolithic, like it's not separated into a lot of different modules, as you might think with a hierarchical approach. It is to an extent, because you can only go so far. So what an entity component system tries to do is fix all this problem by making the entity the entity doesn't have any specific variables. All it has is a list or a dictionary or something of components. And components are the actual separate objects that have the values. So for instance, this entity right here has a body component attached. And the body has a position X and Y and a size and a height. It also has a sprite component. It has a sprite, image, quad, and all that. AI component, and then entity or enemy. Oh, let me go back. Enemy components. So you can kind of compose these entities by adding all the components that you want. So if you want to create a ninja, well, the ninja is going to need a position. It's going to need a body, right? It's going to need a physics component. It's going to need a image and a sprite. And you can kind of take a entity and just add the features you want, and it'll just work. And that's the magic part of an entity component system. Another aspect of it is a system. Now, a system, like all these components, all they contain are variables. They don't contain methods for updating or moving the entity or using them. Usually, you can do that, but it's a lot safer and a lot better if you actually create something called a system. Now, there's a world and then a system. A world contains entities, and it contains the systems, and it tries to match the entity to the system. So it's kind of hard to explain. It'll be a lot clearer when we're in code, but a system basically says, I want an entity that has a body component and a sprite component. That way I can render this entity. So the world's going to be like, okay, so it wants a sprite and then it wants a body. So let's look through this list of entities. Oh, I found one that matches that requirements. So I'll pass that entity into the system's rendering function, whatever that may be. That's just a brief rundown. It's a little bit complicated. If you want to do more research on it, I definitely recommend you go to Wikipedia. There's tons of resources. It's a very popular way of doing things. So let's get started today. Let's actually build this thing. So we got a little project. Let me close down my slides right here so we don't have that running in the background. So we just have a little love project right here, right? We can compile by saying Control-Shift-B. hopefully. And yeah, I'll just bring up a window. Very nice. So this series is going to be broken up in several parts. The first part right now, we're actually going to be building this entity component system. The second part, we're going to be using it and showing you how you can use it. And the third part, I'm thinking about making it so you can, or actually, the second part, we're going to be extending it. So finding cool ways to create entities, like for instance, from a table. And then the third episode, I'm planning on making a game using the entity component system, so you can see kind of how to use it, how it's, why it's actually really useful. Whew, that was a lot of words. Let's actually get started. So the first thing I'm going to do is I'm just going to create an entity. Let's just create a file, name it entity, make it a Lua file. Let's just return a table. We're going to have a new function, and then we're going to create a entity table inside here. I'm using Visual Studio Code for this, by the way. It's becoming my de facto editor, that and Vim. Okay, so let's remember back what entity has. As you can see, it just has a list of components and maybe a flag that says remove or something. So let's actually create that list of components. We haven't actually defined what a component is yet, but we're just going to create a table named components. All right, and then also I'm going to have an optional table called tags. So you can add, specific, like, let's say this entity has a enemy tag, so that if a player collides with the enemy, it can view that tag and see that, oh yeah, I need to take damage or something. I don't know. It's a useful little feature right there. And then we're gonna have a remove. And this is used for the world later on. So we're gonna create a couple functions for the entity. We're gonna add. Then we're gonna have a component. Oop. Now the component is gonna have a ID. So let's make sure that we assert that the component has an ID. If it doesn't, we'll just leave it as an assert. So now we're going to say self.components at component ID is equal to component. So that we just added basically all that does is add a component to the entity. Then we're going to have an entity get. We're going to pass an ID. Oh, let's just return that component. So self components ID. All right, so actually I'm going to, real quick, let's take a little break. We're going to create a little file called utils. This is going to create some common, fun, like, functionality and stuff like that. All right, so in here we're just going to create one function right now. It's just going to be table.new. All this is going to do is going to create a table. I found this code online. It's not mine. I don't know where it's at. I think it's just a RAM tutorial. So let's make sure that we're just going to check the type of the original, make sure that it is a table. Then we're going to make a local copy. Okay, so if the original type is equal to a table, then we're going to say else. If it's not equal to a table, then we're just going to say set the copy equal to the original. Then we're going to return copy. This is a recursive function, so it's very fast. It's very nice. I really like recursive functions because they make your code a lot shorter and smaller. So we're gonna loop through this this table and just copy each value. So let's make a original value in next orig, then nil, and then do. All right. I don't know why this works. Honestly, I'm not a Lua connoisseur like this, but hey, it works. I'll take it. The reason why we need this function is that if you just say table is equal to this other table, it doesn't actually copy it. What it does is it copies the reference to the table. So you're actually this used to confuse me when I was learning Lua and all that. This used to confuse me when I was learning Java and stuff. I couldn't for the life of me figure out why my stuff wasn't working. I'm just opening up my notes right now, just so I can see what we're going to do next. Let me go back to entity. I think yeah, okay. Okay, yeah. So, well, actually, I'm not going to do this real quick. Sorry, I'm just thinking out loud. Let's create a actual component now. So let me open up my notes and let's go over here. So the component's going to be super simple. All we're going to do is return a table, make it equal to function. This is required, so we're going to say ID. We're going to assert that the ID is not nil. We're going to create a component right here, and we're going to give it the a property called ID. Then all we're going to do is return this component. Again, it's just super simple. Next, let's create a system. So I'm going to open up my system notes. Let's go over here. Let's say system.lua. Alright, again, we're just going to return. Super simple. We're going to do this a couple times. Okay, so now the system takes a table. It takes a table of something called requires. And requires are basically just IDs that each component has, basically. So it's like this system requires a body component and a sprite component to be able to render, because you need to know where it's going to be rendering at and what to render. Yeah. Anyway, so yeah, so we're going to create, or let's assert that the type of requires is actually a table. Then this, we don't really need an ID, actually. Yeah, we don't really need an ID, so I'm just going to remove this, just to make this easy. Okay, let's see. Let's create a local system table. Return system. Let's say requires is equal to requires, just like that. Next, we're just going to create some functions that the system is going to have. So it's going to have a load function. So as soon as the entity is created, it matches the required signature, then it's going to pass through the system load. Only once though. Update will do the same thing, but every tick, every frame. Draw will do the same thing, but again during the draw cycle. I'm sure you guys understand how this. If you don't understand how this works, well, at least you have some code that you can use. UI draw. We might be using this later. This is basically going to be drawn before this one draw. So if you want some entities on top of the other one, normally I would be having a renderer do all this, the layering and stuff like that. But for this series, I mean, you can transform this into whatever you want. Last thing is a destroy function. This is called when the entity is told to destroy itself. Actually, I forgot to do that. So let's go over to entity and let's add that function. Ooh. So the destroy function, all that's going to do is going to say self.remove equal to true. All right, so we got a system. Okay, so this is where a lot of the magic happens. This is something called a match. We're gonna have. What am I trying to say? We're gonna create a match function. So what's gonna happen is the world's gonna pass this into. It's gonna loop through all the entities, then loop through all the systems, pass the entity through that system or the system's match. If it matches, then it'll do the code. Now there's a lot of what am I trying to? Let's just say do match. There's a lot of ways to make this more efficient. This isn't the most efficient, but I mean, you can easily push 1,000 entities on screen. Like, you know, it's not super efficient, but you don't need it to be. If you want to, you wouldn't do particles using entity component system. You would use a different system. This is for entities, like, I don't know, like you have a couple mobs or something. I don't know. You know, it's up to you. All right, so. What we're going to do is we're going to loop through the table of requires, right? We're going to say if entity get, and then we're going to say self.requires. So we're going to try to grab that entity at index I. If it's equal to nil, if it's equal to nil, that means the entity does not have the required component. So then we're going to return false. Else we're going to return true. Alright, so I think that's just about it. Now we need to create the world. This is where it's going to tie everything together. Okay, so up at the very top, let's include the entity. We're going to create, we're just going to return the world, or better idea, we're going to create a module. We're going to name it world. I think this is a little bit better of a way to do it. Return world. Alright, so world's going to have a table of entities and a table of systems. And I think that's, yeah, now let's create some methods. So world register. So this is where we're gonna register a system. And yeah, let's just say system. I was gonna say maybe we need to do this with a hash map, but I'm gonna avoid that. I'm gonna say self dot or table insert self systems. Again, if I were doing this in a actual game, I would make a local insert variable, things like that. There's a lot of ways you can make this better. I think that's actually all we need for that. Let's make it so we can update. Then draw. One thing I need to add to the entity, we need to make sure that, so we're going to say loaded. We're going to have a tag called it loaded. If it's not loaded, then it's actually going to pass through all the systems and load it, essentially. So, alright, things are going pretty good. Let's create a function to create an entity. So we're just going to have a function that creates an entity, and that just makes it a little bit simpler on ourselves. Let me think. Yeah, let's do this. Local entity is equal to entity.new. Then we're going to return that entity. And we're going to say table insert self entities entity. All right. Now that's looking pretty good. So in the update, we want to loop through all the entities now and update them, or loop through all the entities and pass them into the systems that they match up with, so that they can be updated. So we're going to say for I. Now we want to iterate through it backwards, through the loop backwards, or the table backwards, because we're going to be popping elements like entities if they get destroyed. So entities 1, we're going to go till 1, and we're going to iterate backwards. All right, so we're going to create a local reference to the entity, just like so. We're going to say if the entity wants to remove itself. Else, we're going to do the actual update. First thing, let's go back to the entity and see if we have the destroy function. We do. Okay, so we're good. We're good. So if it needs to remove itself, we want to loop through all the systems. So fry system in I pairs. Again, if I was going to make this more, if I was going to make this faster, I would not use an I pairs loop. I would just use a standard, loop. Okay, so if system match entity, then, so if we match the system with the entity, then we're going to say system destroy entity, just like that. Yeah, it's as simple as that. And then we're going to say table.remove self, the table that we want to remove from is entities, and then I, like that. All right, so let's copy this so we don't have to write this a couple more times. If entity.loaded is equal to false, then we're gonna pass it through all the load functions, just like that, and then we're gonna say entity.loaded is equal to true. Next, we're gonna do the exact same thing, but for updating. Oh, actually, we could do this so much more efficiently. I don't know why I'm doing this like that. I wrote my notes when I was really tired, so okay, so if entity.loaded is equal to false, then we're going to say load the entity, like that. Then we're just going to say entity.loaded is equal to true, and we're just going to always set that every frame. And then system update, pass in delta time, then the entity. Let's make sure we're getting delta time. All right, cool. So that's it for updating. Let's do the same thing for drawing. So we don't actually have to iterate backwards this time. We don't really want to iterate backwards because then we'll draw the entity in reverse order. if we had a render, this wouldn't really matter, but whatever. Okay. Paste that in there. I'm going to say if it matches, what we're going to call is the draw function. Let's remove the DT. And I think we're good. So let's do some tests. This might be a long video. We'll see. Let's see where we're at. We're at close to, I cannot tell. Oh, it's not too long. Okay, good. Okay, so let's require the world. Let's say local world is equal to require. I don't know why my syntax highlighting isn't. Okay, it is working now. Require world. All right. We're gonna say world update, pass in delta time, world draw, like that. Let's make sure. Let's build. We haven't built in a long time. All right. So 33, we have an issue. Oh, so used to Vim, I am doing some crazy Vim keys. All right. So we have equals equal, or we don't have equals equals there. That might. Okay. So we look like we're good. We look like we're good. All right. So let's create an entity. Let's just see if this works. If I can spell, that'd be very nice. World create. All right, we created an entity. Let's create a component. Equal to a function. Oh, let's not do that actually. Function new body. Sure. X Y. Return, or let's say local body is equal to. Let's include the component. Like that. Let's make it equal to component.new. And here we need to pass in an ID, so we're going to say body. That's very important that you memorize those IDs, because they need to match up with the system. It needs to be spelled the same, basically. Return body, body.x is equal to x, body.y is equal to y. We're just going to do an x and y for now. And then function new rectangle renderer. And then all this is going to do is return a component. You might want to have like a component, like a well, actually rectangle component. It's a little bit of a bad name. Whatever, you know. This is just for testing. So we got two components here. This rectangle component, all it's going to do is going to say, yeah, draw the entity. We could add a color in there. We could add, you know, stretching. We could add maybe even like a shader or whatever. But we're not going to do any of that. So if we got two components, let's add it to the entity. New body. Let's put them at 100, 100. New rectangle component. Build it, make sure we're good. We are good. So now let's create a system to render this stuff. Gotta be careful when I type. Alright, just like that. Let's include system. So now, when you only have like a few components, this doesn't seem like a very effective, you know, the entity component system doesn't seem very effective, right? It doesn't seem like it saves you a lot of time. But when you have like 100 different components and stuff like that, and you want to snap together an entity like instantly, like let's say you create a sprite and you just want to test it out. Well, instead of writing a new class, compiling, and all that crap, you can just literally just write a table and give it the animation that you want, and it just works. It's really nice. Equal to system new. Let's pass in a table of required. So it's going to require a body and then the rectangle. And this corresponds to these tags right here. Like that. To return the renderer, let's extend the renderer draw function. First things first, actually, let's make sure that our entity is being it is found by the system. So let's say print found one. Sure. If we build it, we do not have anything because we need to register the system. So world register. Oh boy. New render system. Oop. Open up a new window accidentally. All right. So we're not doing anything. Let's make sure that we're actually... Yeah, I'm going to do a lot of the debugging and stuff live, just so you guys can see my process. My process sucks, by the way, for Lua. Okay, so we are looping through that. Oh, okay, so it looks like the destroy tag... Yeah, I don't know why I set that to true. That's really strange. Okay, so we found one, but we have an error. System 10. So let's go over to system. Check out 10. Entity get requires, stuff that requires is equal to nil. What was the error? Let's check it out. Attempt to index the entity. So are we not passing in the entity correctly? Let's see what the entity actually is. Alright, so it is a table. Did I match entity? Alright, let's say print entity get body. Alright, so we are getting a table. We are getting a table. Where's the error happening? So it's starting in... Okay, so it's in the draw function. Okay, so we got an issue there. Gotcha. Yep. Yep. Obviously, we need to create the entity right there. So we found one. We're not rendering anything, and that's because we didn't actually draw anything in this... right here. So we want to get the body, right? So we want to know where to draw it. Let's say love.graphics rectangle. Let's fill body.x, body.y. Let's just make them a size of 32. Because we didn't specify that in the rectangle. Alright, so we're drawing an entity. That's awesome. Now let's make sure, if we remove this rectangle component, we shouldn't be drawing him because he doesn't match the components. And if we say entity add component new, if we just add a random component, we need to make sure we have an ID. Hello. It'll still match with the system because it still has the required systems of body and rectangle. So I hope you guys enjoyed that. A little bit of a long episode. Next time we will be creating entities on the fly using tables and stuff like that. And then third episode, again, we're going to be creating a game with it, so I can show you how to actually use it. Why this is so effective and all that. But anyway, guys, thank you for watching. Please subscribe if you haven't. Give this video a like, and stay tuned for the next episode. Anyway, peace out.